2. Hey, what's up guys, this is JAVATHAN and this is a video on what is Java exactly. What is the Java platform? So Java is a oriented programming software that incorporates polymorphism, abstraction, encapsulation, and inheritance all into one so that we can communicate with the computer, so we can run programs through algorithms. And it does it using a compiler and interpreter. The compiler translates source code into another language, into machine language, which is bytecode. And the interpreter translates the bytecode into machine code so you can access it on all different types of platforms. Now, before we start speaking about the platform, or to understand what the platform is, we have to kind of like fucking go way back. Let's go way back to the beginning of what is a computer. Like, what is a computer? The computer has a keyboard and shit, and it's electronics, and it's able to make computations. It can display data and it can store data. So the PC part of the computer that displays the data, the processor is the brain. It does all the thinking of the data. And before I go any further, actually, I forgot to mention that Java is not JavaScript. Two completely different things. So back to what I was saying. The computer only understands electric signals, ones and zeros. 5 volts is a binary 1 and 0 volts is a binary 0. And the PC is continually fucking shot out with these pulses, and they have to be interpreted so that the computer can understand what the fuck is going on. So 8 bits of signals are grouped together, and these signals and these 8 bits represent text, digits, and characters, and these are all patterns of electronic pulses. So for example, an 8-bit code of 01001101 is the pattern of 8 bits used for the letter M in binary code. That's called 8-bit computing. That's a quick example of what that is. So if your processor is a 32-bit processor, it takes 32 bits at a time, if that makes sense to you. If your processor has a 64-bit processor, which is very popular, Intel 64-bit processor, it takes 64 bits at a time. So back in the day, you'd have these big-ass, huge computers. I think it was called the Circa computer. It's like that big-ass computer they use in Dexter, that Dexter uses in his lab. So now, suppose you want to add 3 and 4 together. To write machine code into that computer, you'd have to write the assembly language code, which are all the ones and zeros, then punch the machine code onto punch cards and feed it directly to the computer. And that shit was fucking crazy hard. Like, it'd take days to do that. So eventually a program called the assembler came along. You no longer needed to make the cards. You could directly type the program into the PC using the program assembler. It pretty much meant you have to write all the steps out. So like, let's say you wanted to add 3 and 4 together. You'd have to store the 3 at memory location A, store the 4 at memory location B, add the contents of A and B together, and store the results of A and B. That would be your steps to adding 3 and 4 together. You'd give these steps to the assembler, which you would type out and give it to the assembler, and the assembler would translate that into the ones and zeros for the processor to run onto its machine, so it could understand, hey, I want to add 3 and 4 together. Let's fast forward a little bit. Now, more and more software languages come out, and like one of the cool first ones that come out is a software language called C. And what that did is it shrunk all these assembly steps that we did into one piece of code, which was printf 1 plus 2. And the compiler would convert that 1 plus 2 into the assembler, which would convert it then into the machine code, the ones and zeros, to the PC. What software languages like C did was that you just have printf 3 plus 4. It would be compiled into assembly language, into probably a bytecode for the assembly language, and the assembler would translate that into the ones and zeros needed for the computer. This is where Java comes in. There's a whole bunch of different platforms, and every platform has a processor and an operating system. So let's take Windows and Intel, for example. Windows is the operating system that runs on the Intel processor. Okay, so Windows is the operating system, Intel is the processor. Both together is a platform. You have an operating system plus a processor that equals a platform. There's other types of platforms as well. AMD is an operating system and Linux is a processor. Together they make the AMD Linux platform. Mac is an operating system, OS X is a processor. Together it makes the Mac OS platform. Now, a change in processor means that the assembly instructions change as well. So like, I could have instructions for one platform, for the Mac OS platform, that won't run on the Windows Intel platform. I could have one set of instructions that run on the AMD Linux platform, but don't run on the Mac OS platform. And so for that, we would need separate compilers, and we can't just have a shit ton of separate compilers. And now this is where Java gets all its fucking fame from. It's like, I want my software to work on all different platforms. And we don't want to buy different compilers to do that. So what do? We invent a virtual Java machine. A virtual machine that everyone can download, and through there, we can run our codes through. So everyone who has Java can run Java files. You guys kind of get it? So in Java, you have a system out print, which is your .java file, which gets compiled into bytecode, which are your ones and zeros. These ones and zeros are not understood by the platform yet. It gets translated into a .class file, which goes into the virtual platform. You guys understand? So you don't go directly from the code to the computer. You're going from the code to the virtual platform. And the virtual platform identifies the actual platform, whether it's the Mac OS, the Windows Intel, or AMD Linux platform. It identifies that platform and converts the bytecode that you originally had into machine code. So that's what Java does. Once the code is compiled, it can run on anything supporting Java. With that said, that's a little background on Java, like why it was created, and since then it exploded. It was created in 1991 by Sun Microsystem, and it was originally designed, I think, for fucking home appliances or some shit. And then in 1995 it just spiked up. And yeah, that's Java for you.